Hi everyone. So today we're going to move beyond just looking at how distance and time covary and start to focus on some other quantities. And to help me out, sort of to introduce you to these quantities, I have in front of me two vases, because what we're going to be looking at is we're going to be looking at some vases and some quantities that involve putting water into these vases. And so that's what we're doing. We're going to be filling these vases with water. And so you might immediately go, ooh, I know a quantity. How long it takes to fill the vase. Yes, that is a quantity. I could measure it, but I don't care about it. In fact, we're not going to care about time at all. And you might be going, oh my goodness, you're going to ask me to sketch a situation with no time? Yes, I am. And it's going to be okay. So there are other quantities that are involved when I fill a vase with water. The first thing is the amount of stuff that I put in it. So what would that be? That would be a volume. So we're going to be looking at the volume of water. And so we're sort of going to be saying as the volume changes, and you might be going, well, isn't the vase just the size and it doesn't matter? But we're going to slowly be adding to the vase. So for example, here's my little random measuring device, and I'm going to take water. I have a little bowl of water back here, and I'm going to put some water into the vase. So now I have put some volume of liquid into the vase. And so as I add liquid, something happens. Well, the vase starts filling up. And so I put some blue tape on here because this vase is a little hard to see. And that represented sort of the bottom level of the vase. But now if you notice, now that I've added some water, the water level is up a little higher. So I could, and I'm using tape here to help me, I can go in here and I can say, okay, well, now there's my new water level. After one sort of scoop of water got added to my vase. Okay, well, what would happen if I added another scoop of water? Well, now, surprise, surprise, the water level went up again. And so now my water level is up here. Obviously, I did a really bad job taping that, but you get the point. So as I add more and more water, my water level goes up. And so that's sort of what we're going to be looking at. We're going to be saying, okay, as I add more water to this vase, what is happening to the height of the water within the vase? And so some of the things you're going to need to think about is how does the size of the vase impact that? You know, as I'm adding equal amounts of water, you know, what's happening to the amount that height is increasing by? Like if I were to predict here, do I think it's going to keep going up, you know, each scoop, will it keep going up the same amount? Like, you know, what's happening on the inside of this figure? Versus, you know, if I had a vase like this and I started adding scoops to it, you know, what's going to happen as I add, you know, equal amounts of water? Will the height keep increasing by the same amount every time? Or would that increase in height differ? Would that height maybe go up by a little less, you know, because the vase is a little wider, or, you know, a little more because the vase is a little narrow? And so those are sort of the thinkings that you're going to need to do. And the hardest part with this is you're not going to have the vases in front of you. I'm providing you with a picture of the vase, but you really need to sort of think about, you know, what happens. And maybe something you could do to help is go into your kitchen like I did and grab a container and start filling it with water. You know, take some scoops of water and put it in and just look at what the height is doing in that container and sort of really try and be like, oh, this type of container would result in, you know, if I added the same amount of liquid every single time, what's happening to that in that water level? Hopefully this helps you get started. Flip ahead to the next slide to check out some of our example and practice problems with this.